Okay, in this problem, we're looking at a television and we have the average price and we have the standard deviation. And what we want to do is find the probability that the television sells for less than 700. So, what we want to do when we're doing probability is get us a z-score to tell us how far 700, how many standard deviations that is away from the mean. So, all right. Let's look. So, the mean is 830, the average. So, the average is 830. Now, when we put the average mean into a z-score, that's going to represent 0. The average is always going to be 0. So we have converted $830 to the z value of 0. Now, the normal distribution, the standard deviation is 150. And we're trying to find the probability that x is less than 700. So 700 would be to the left somewhere of 830. So it's definitely less than the mean. So we want to know the probability of it being less than. Now, you can't look up 700 on the table. You have to convert this to a z-score. So the z-score is x minus the mean divided by the standard deviation. And really, we could probably let's look at the formula. Okay, yeah. So it is the population standard deviation. So I'll put that back. So we know that x is going to be the value that we're using. The mean is 830 and the standard deviation they gave us is 150. So this is definitely going to be a negative number. 700 minus 830 divided by 150 is negative 0.87 if you round. So we want to know the probability. So this as a z value is negative 0.87. So we want to know the probability that z is less than negative 0.87. We're going to use that to look it up on our table. And I'm not sure if they give us a table here. So what we can do one or two things. So this particular problem, they want you to practice using Excel for this, which you could technically use a table. So just go into Excel and put equal, normal, and you want the dot dist. And then X we said was 700, and I believe the mean was 830. And then the standard deviation is 150, and make sure you're putting commas in between. And you want it to be cumulative because you want it up to that point. So you want true and close it and press enter. So what that is telling me is this probability here that I want of less than is 0.19 if you round. So there's a 19% chance that the TV could sell for less than 700. Not a very big chance. Oh, sorry. They want us to round to 4 decimal places. So 0.1931. 0.1931. So the next part wants to know the probability that the television will sell between 500 and 600. Now I'm going to guess that that probability is going to be even smaller just because it's getting further and further away from 830. Of course, it is a bigger range, so it might not necessarily be true, but let's just see. So 830, remember, is the mean, which would be 0. 500 would be over here somewhere, and 600 would be over here. And we want to know in between. Now, first we have to convert these to z-scores. So remember, we have to do x minus the mean divided by the standard deviation. For both of these, we have to get 2 z-scores here. So we're going to do 500 minus 830 divided by 150, and we're also going to do 600 minus 830 divided by 150. So let's get both of those z-scores. So we have the z-score for the 500, and I'm going to write it up under that. And what that means is 500 is approximately 2 standard deviations less than the mean. And then this one is approximately 1.5 standard deviations less than the mean. Now we need to look these up using, let's just use the same thing, normal. Now the x is for the 500. Let's do that one first. 500. The mean is, let's see, the mean is 830. And the standard deviation, so technically you don't have to do the z-score since you're using Excel, but I like for you to convert the z-score so you could look it up on the table if you had to. The standard deviation is 150, and we want it to be cumulative. Let's see, we want it to be true. I guess we type in true. So 0.0139. So from here to here is 0.0139. Now let's do the 600. So x is 600. The mean is 830. The standard deviation is 150, and it is cumulative. .0626. And I'm not sure about the rounding on this one. So if we miss it, so now we want to do 0.0626, the bigger one minus the smaller probability, to get the in between, and you will get not negative, 0.0487. Let's just see, and we can always backtrack if we need to. Let's see what they use. Okay, so I put a 2 in there, and that threw it off. And then between 950 and 1050, you would just put it in Excel and get your z-scores and subtract. I'm not going to draw it this time. So 950, I believe, is what we said. The mean is 830, the standard deviation is 150, and we want it to be cumulative, so we put true. And then 1050 is the other number, so we put in the normal. Now, so we take the we take 0.9, you can do this in your calculator, we take 0.928, the 7 will round up to an 8, minus 0.7881, and we get 0.1407. The price intervals in part B and C are equal 100. Why are the probabilities so different? Because the 500 to 600 is closer to the mean of the distribution than the interval. The closer it is to the mean, let's see, 500 to 600 is closer. 500 to 600 would be 200 and 100. Hold on, the mean is 830, isn't it? So 950 is actually closer to 830. So I had that backwards. So if it's closer, the probability is going to be higher. All right. Suppose a couple's shopping and they have a budget of 800. How many televisions are within their range? So you would find the probability that X is less than 800, like we did in Excel, and I did that, and I got 0.4207. So what you want to do is do 0.4207 times the 18 televisions to see how many you could buy, and it's 7.5. So that would round up to 8. You would be able to buy 8 televisions. Let me know if you have any questions. This problem was lengthy.